Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look at this thing. It was saved from the trash and it was given to me, and I have no idea what it is, and nor did the person who gave it to me. The best I can figure out is that this is actually a hard drive, and all this stuff you see here is the power supply for this thing. So in this video, I want to try to figure out if, well, this is definitely a hard drive, see if I can get this thing spinning, and perhaps through this interface cable here, actually get this hooked up to something. Maybe we can read something off this thing. My hopes aren't high though that this is actually gonna work, so this may be nothing more than an exploratory video, but I figured I'd take you along for the journey because this thing's been sitting on the floor for a while, and I figured it's now time to take a look at it. So without further ado, let's get right to it. Alrighty, so the anatomy of a mystery hard drive. I have this thing sitting on the 70s towel because the whole thing is extremely heavy and hard to move around. But here is the front of the drive, and take a look. There's actually a sticker with a part number and a serial number on it. It appears to be a Japanese brand name, Hokushin, made in Tokyo, Japan, part number CD8010P, and there's a serial number there. Now, judging by that part number right there, I'm guessing that this is an 8-inch hard drive, 10 megabytes in capacity. That would be unformatted capacity. Whoever owned this before obviously mounted the two power supplies here and this hard drive onto this piece of plywood here. The whole thing is extremely heavy. It's really actually quite difficult for me to move around. Obviously, in a video, you can't tell how heavy something is, but I am guessing that this probably weighs about 50 or 60 pounds. Now, it's pretty clear that these two things right here are power supplies. We'll take a look at the wiring in a second. I think this one here had a sticker on it, and it was this one. It just fell off. Perhaps someone might recognize the brand or part number that might be on here, but it looks like just a warranty serial number sticker and nothing more. On the front power supply here, which I've written a little number 1 on just to help me identify it, this has the mains AC input. Now, this is most definitely like a lamp cord or something like that. This is not really an appropriate cable for this type of things, but obviously this was very homemade. The AC mains cable is just connected right here on this power supply. There's a couple lugs there, and then from that we have some wires here that go to this AC cooling fan. This is a 120 volt fan which just blows air across these two power supplies, and then there's another couple thin wires that go into this transformer right here, which then feeds power supply 2 and power supply 3. I took a very careful look at all the connections on these 3 power supplies, and there's absolutely no writing as to what voltages they might be. They do all connect to this somewhat chunky rainbow ribbon cable, which then comes over here to this harness, which plugs into the disk drive's controller and has a wire here that goes into this second PCB that's attached to the drive as well. I'm forgetting where I recently saw one of these, but this appears to be an hour meter that's attached, and it goes off to one of the power supplies. Is this, oh, okay, you can just lift this off here. It may not be too easy to read, but someone wrote on the wood here with a piece of pencil, 2,000 hours, March 26th, 1984. So someone's just keeping tabs on how many hours this drive ran. Perhaps these old hard drives weren't known for their reliability, and the more hours you used it, the more likely you were to lose your data. Spinning the drive around, take a look at this. This is the digital electronics section of the hard drive. And actually, there are 2 PCBs sandwiched in here. This is an extra adapter board that seems to be in addition to the built-in drive electronics that is on the actual hard drive. The PCB that's towards the camera is what's connected to this ribbon cable here, which seems to be a 40 conductor cable, and then it has a 50-pin connector on it. And it's a little bit lengthy in that this was probably put away from whatever computer it originally connected to. Now, removing this cable here reveals that this PCB here is actually connected to the other PC through a 50-pin cable. And I'll get to what my thoughts are on this cable in a second. In addition, down here on the corner, there's a little power connector that has a red and a black wire that just goes up to this power harness up here. And I have validated that the red is 5 volts and the black is ground. And that's very easy to do when you have a ton of TTL logic like this. You just look at the red wire if you think that's 5 volts, and check that you have 0 ohm continuity to the 5-volt pin on the TTL logics, same for the ground. I'm going to try to release the clips to get this PCB off, and I'm using a Bic pen that a viewer sent in. It's a Bic pen with the actual ink removed, because this appears to be the perfect tool for this, actually. Whoop. With this board off, I'll bring it over to the bench so we can use the better camera to take a look at the chips a little closer up. I'm going to disconnect the 50-pin cable there. Alrighty, and there we have the hard drive's PCB, which seems to be pretty complicated as well. We have an EEPROM, a couple 40-pin dips. We obviously have some voltage control stuff over here that might be for controlling the stepper motor that moves the head around or starting the spindle, things like that. Now, one thing I find very interesting is this 50-pin connection here. There are actually 2 connections with this 50-pin ribbon cable, and one of them has what looks like a Terminator module in it. These are resistor packs here, and I think what that means is that this 50-pin connection might be SASI, S-A-S-I. This was the precursor to the SCSI interface, or Small Computer System Interface. I can never remember what SASI stands for, but I think it might be System Attached Storage Interface. Either way, if it is SASI, that means that it may well be possible to connect this connection directly up to a SCSI controller, because as far as I'm aware, SCSI and SASI are actually intercompatible. Well, more so that SCSI is backwards compatible with SASI. Of course, it's not the other way around. We do have some dip switch blocks here and here, which would imply that maybe this one over here, since it's near the connector, might be the equivalent of the SCSI ID setting or the SASI ID. I see down here at the bottom it says main CB or circuit board, and then CD8000P. 8000 must be the model line of this hard drive, and then the name of the company that made this thing. Now look at this PCB. You'll notice that there are these white strips that run up and down across the board. I'm pretty sure this was a design to allow the manufacturer to give 5 volts in ground to all the ICs, and it looks like bypass caps as well, because you notice there aren't very many bypass caps on the board. There are some tantalum spread around, but generally every one of these ICs should have a bypass cap, so perhaps this strip is doing double duty. We do have some LEDs, like maybe they're diagnostics or status LEDs. There's 3 there, another 4 there. And this large 40-pin package here is Intel, or it's an NEC, but it's an Intel 8085 processor. And this IC here and here is the support logic for that, and almost certainly this is the boot ROM. It was pretty common for hard drive controllers in the 80s to have a hard drive controller chip on the actual board, and then ribbon cables would go out to your hard drive and then, actually move the heads around and stuff like that. That's how MFM or ST506 drives worked. But that hard drive controller, which is actually usually made by Western Digital, started life as a full-size PCB, kind of like this. Maybe not as many chips as this, but it was a full-size PCB. And the way the processor communicated with the external board over a ribbon cable is basically the same way it would communicate with that IC controller that's on the hard drive card that might be in a computer. So Western Digital took that full-size controller and shrunk it down. A typical IC on a hard drive controller would be hooked up to the data bus, a couple address lines, a chip select line, stuff like that. Well, it's absolutely no different with those larger PCB-based hard drive controllers. It was actually pretty common for machines like the K-Pro, which might not have had a built-in hard drive support, only certain one did, to have a PCB made by Western Digital often that would connect to the CPU's data bus, and it would be treated just like one of those controller ICs, and then out of that card that's in the K-Pro would be the connections to go to a normal MFM or ST506 hard drive. My hunch is this PCB here does exactly the same thing. The 40-pin connection on here is what goes to the CPU. It has the address lines and stuff like that. It probably follows a similar standard to that Western Digital controller, but it may not. Of course, if you're used to the IBM PC with the ISA bus, well, they took the large controller, made it a single chip, stuck it on an ISA card, added some support logic, and then that's what talked to the hard drive. So over on the bench here, let's take a closer look at this adapter board or whatever this is. Now, unfortunately, it doesn't have any actual markings on it as to who makes it or a model number or anything like that. I kind of have the assumption that since it was attached with those clips onto that drive, that it was made by the same manufacturer, probably as an optional board to interface to computers that didn't have SASI, but I'm not totally sure. Looking on the bottom of the board here, we have a fab marking 200107 and EC1283, whatever that means. Unfortunately, that's it for markings on the underside. There is nothing more than that, just a lot of traces. So like that other PCB, this also has an Intel 8085 chip. We have a couple ROM chips. We have a couple static RAM chips. These are 214s, so that's normal 2K SRAM. And then we have one more ROM chip over here, and then a whole sea of TTL logic on this thing. There are some jumpers on the board. They're all labeled W and a number. There's another one. And there we have two more next to the power connector. So perhaps with my viewers' eyes on this board, people can identify what this actually might be. Looking at the ROM chips, these two are 2516s and this one's a 2732. So I think with the Retro Chip Tester Pro, I can actually dump the contents of these. So I'm gonna do that right now. Alrighty, just like that, I've gone ahead and I captured the ROMs. So I took the three that were on this adapter board here. Incidentally, TMS 2516s have the exact same pinout as 2716s from every other manufacturer. For whatever reason, Texas Instruments made the 2716 have other voltages that aren't normally on EEPROMs, I think plus 12 and minus 5. So you cannot use a TMS 2716 interchangeably with other brands, but the 2516 is interchangeable. Not sure about programming, but at least for reading. I also went ahead and I grabbed the ROM that was off the hard drive as well, and I have gone ahead and dumped that. So let's quickly take a look at those in the hex editor and see if we can see any code that might give some secrets away to what this board is and maybe what the hard drive is all about. Here are the files, and I'll upload them to archive.org in case you want to take a look at these yourself. Of course, they're 8085 code, so they could be run through an emulator or disassembled relatively easily. That, unfortunately, is a little bit above my pay grade. My assembly language days are long behind me. I decided to use Notepad++ just because it'll be a little easier for us to pick out any strings that might be in here. And so far, this is the ROM from the hard drive. Not seeing anything. Just a bunch of code. Yeah, not much going on there. Let's take a look at, let's see, which one is the larger one? This is the larger one here. This is the 2732 that's on the adapter. Not seeing anything either. Nothing at all, just a little bit of padding at the end of the ROM. And then this ROM here, this doesn't seem to have anything in here except maybe like a lookup table or something like that. Don't think that's actually program code. And the final ROM, here it is. Seems to be random enough to maybe be program code, although I don't think so. Nope, nothing there either. So nothing revealing in any of these four ROMs. So like I said, I'll upload these so maybe someone else can pick something out of these. Okay, so the next logical thing I think I need to do is start doing some research to see if I can figure out if I can find any information on that hard drive whatsoever. I'd like to know if it is SASE for sure, and I'd like to know what the power connector voltages are and the pinout. It's using a normal like Amphenol type power connector that was pretty common back in the day. 8-inch disk drives use the same one, but I did a little bit of poking around on there and it does not appear that it uses a standard pinout. I think I can figure it out for the most part, but I'd like to find some documentation if possible. So after searching, I found absolutely nothing. I could find evidence that Hokushin was an actual hard drive manufacturer, like they made hard drives, but I found nothing specific on the CD8000, which is what's marked on the PCB, or the CD810, which is what's written on that sticker on the hard drive. This Wikipedia article on defunct hard drive manufacturers does list Hokushin Electric Works as a company. Let's check the citation. And here's the article. It's talking about a parallel trend between Japan and Europe, I guess doing hard drives maybe. NEC, Fujitsu, Hitachi, and Toshiba all entered in the mid to late 1960s. And then in the 1970s, old Japanese companies attempted to market disk drives to non-Japanese customers in the US market. Until then, the size of the market for the Japanese computer limited the market size of their drives. A smaller domestic market also meant fewer independent Japanese drive companies entered in the 70s as alternative sources of supply, namely Mitsubishi and Hokushin Electric Works. I did find this, which seems to be a patent taken out by Hokushin for a hard drive, but I did look at this quickly and it appears this seems to be like a 5 1/4 inch or maybe even a 3 1/2 inch hard drive that is MFM or ST506 based. Definitely not this. There is one reference down here in the document, Hokushin Electric Works Limited CD8000, expand your system versatility with a low-cost 8-inch Winchester from 1980. CD Space 8000. So I am putting out a call to my viewers. Can anyone be a super sleuth and maybe find a little bit of information about this CD8000 line more than the couple things I just found? It would be pretty helpful. But okay, let's get back to it. Let's see if I can figure out how to power this thing up. So I took a close look at the power supplies and the cabling that's on there, and I tried just to use some logic to try to figure out what is what. On the piece of paper here, I've written everything that's on the actual drive itself. So that's the connector that goes into the PCB on the drive. That has color-coded wires that are going into it. So we have these 6 wires. Then there's that little pigtail harness that then has the ribbon cable, or that multicolor rainbow cable that goes off to the power supplies. And that is these wires here. Some of them are combined, like black and brown, red and orange, purple and yellow, and blue and green. There's a not connected pin. This green pin on the drive is not connected. And then also there is a white and gray. On the PSUs, remember there are 2 major PSU units, but one of them has 2 little boards inside. So I'm calling that 2 and 3, and then the big one is PSU 1. So PSU 1 has the blue and green and the purple and yellow thick wires going to it. And then PSU 3 is the easiest one to figure out. It actually has 4 connections on it, but it seems that 2 of them and 2 of them are parallel together. But I can easily determine that that power supply is grounded 5 volts because, again, as I mentioned, I can trace the 5 volt connection on the power supply all the way to TTL logic chips on both the PCB on the hard drive and also on that adapter board. So I know for sure the black wire on the drive is ground and the red wire is 5 volts, absolutely for sure. But then that leaves us with 3 other connections. I was able to determine by looking at the PCB on the drive, the actual soldered connections, that this blue wire, which goes to the blue and green, which goes to that large power supply, is also ground. It is actually common on the PCB with this ground up here. So that leaves us 2 connections. One of them goes to the large, big, chunky PCB that's on there, and I'm gonna guess that that is 24 volts. That goes through the purple and yellow wire, so they're common together, and then it goes to the yellow wire connector that's on the drive. And then there's one more pin that is connected, and it's connected on its own to a small little power supply, which the ground wire on that power supply goes off to the ground wire of one of the adjacent ones, but it has one wire that goes to the drive. It's this white wire which goes to the gray on that ribbon or multicolor cable, and I think that's minus 5 volts. The reason why I think it's minus 5 volts is typically minus 5 volts is just a bias voltage, so it's very low current, and the power supply that is hooked up to the actual physical power supply on the unit there is really little. And yet the really big power supply, which is giant, is probably giving 24 volts, which is going to be used for both stepping the heads and turning the spindle. I did a little reading of some documentation I could find on 8-inch hard drives from back in the day, and they used either 120 volts to turn the spindle motor and 24 for the stepper, or they just used 24 volts entirely to run both the spindle motor and the stepper together. Now, what we're looking at here is the actual pinout from the Sugar SA1000, which is also an 8-inch hard drive. It uses the exact same physical connector as this drive. Well, unfortunately, that doesn't match because I've already determined, and without a doubt, that pin 1 is ground and pin 6 is ground on this drive. I mean, there's actually ground traces running right to those pins. But if we take a look at the Sugar SA1000 right here, its pin 1 goes to 24 volts DC plus 24 volts DC. So clearly it's a different pinout. So I can't really rely on that, but I can rely on the numbering of the pins because that's actually silkscreened onto the PCB. So I know that pin 1 is in the same position as this image right here. So that leaves me with this as the idea of what we have. I just added these in. So 24 volts looks to be on pin 2. I can see a thick trace coming from the connector going off to another connector on the PCB. But I can't see, unfortunately, what goes to pin 4 because it appears to be on the back side of the drive, or it's just not connected at all. Could be that too. I think armed with some basic knowledge here, I think the best thing to do now is unplug the power cable from the hard drive and power up those really, really sketchy power supplies. There's not even like a fuse on there or anything, so I better use a power strip so I can turn it on and has a circuit breaker on it in case everything goes bang. All right, it looks sketchy, but I have 3 multimeters connected. This one is here as well. I'm expecting that this one is 5 volts, that's gonna be 24 volts, and this small one here is gonna be the minus 5 volts. I have this whole sketchy assembly here connected to a power strip right here with a switch, so we'll turn that on in a second. And I do have the power connector disconnected from the drive, so that's where the multimeters are connected. I have no idea if this thing is gonna work or smoke or what, but I did give this a quick once over and I don't see anything that's like shorting or that should be bad. Everything seems to be firmly connected properly. etc., etc. So I think, here we go. Okay, 5 volts. Okay, minus 12 volts on the one I thought was minus 5. So that's actually minus 12, and we are not getting anything on that one. Okay, so let's turn this all off. Now, one thing, by the way, is you don't want to necessarily start old switch mode power supplies when you don't have any load on them. But these are both linear power supplies. There's a giant transformer right there, and there's another one inside this metal cage here. So basically, the transformer takes 120 volts, brings it down to something lesser. It goes through a bridge rectifier, it goes through some smoothing caps, and then it actually has a voltage regulator, which is almost certainly what's underneath these two covers right here, and then there's more on the back of this board. They're the large package ones, and they're using this large metal case here as a heatsink, which is why this fan is blowing air across this stuff. They get very hot, they're very inefficient, but they have a nice, smooth, and stable output, but at least they seem to work fine at zero load, while a switch mode power supply, depending on the type, especially the older ones, need some kind of a load or they can get damaged. Specifically, they can run away, the voltage can get too high and it can damage the output caps and stuff like that. But this seems okay, except we weren't getting anything on this multimeter. So let me just double check my connections. And I'm also gonna update this sheet here to reflect that the minus 5 volts is actually minus 12. All right, I just had a realization of what's going on. The big power supply is the one I wasn't getting anything out of. I just realized that the ground output of this is not connected to these power supplies right here. It is connected together once it's plugged into the hard drive. It's actually bridged on the PCB, but the ground lines are separate. So I'm gonna clip the ground for this multimeter right onto here, which I think is the ground, and then this should be 24 volts. So let's hit the power switch. Oh, there it is, 24 volts. Okay, as sketchy as these power supplies are, I don't know what the ripple is gonna be like, but clearly they're all generating the right voltage rails. Wow, okay, that's really quite cool. That is actually one of the beauties of these linear supplies. They're so simple, there's no oscillators or controllers or anything that can go bad. The capacitors only are doing smoothing, and that's pretty much it. So I probably should switch these things over to AC, and I'll just quickly double check the ripple on the output of these, make sure that it's giving a nice smooth output. And I gotta say, under no load conditions, I'm not really seeing any AC voltage on these at all. Now, under no load is like the easiest possible condition, because as you load up these linear supplies, you'll get more ripple. It's just how they work. But the caps seem to be doing some kind of a job right now, so I'm gonna say that they are not dead, at least. So I think at this point, what's left to do is plug that power connector back into the hard drive and see if that thing even spins. If it doesn't spin, obviously there's nothing more we can do really with this video, but if it does, maybe I can hook it up to a computer and get it to do something. How cool would that be? One thing I do want to do is take this fan off here. This thing is way too noisy. It's nice that it works, but the fact is, if you stick your finger in there, chop chop, and of course it makes a real racket. If I ever were to try to use this hard drive, actually use this hard drive, I would install switch mode power supplies on here. You just need to get one that's 5 volts, 24 volts with that minus 12 volts. And then, you know, we should have a much more efficient hard drive. Not that I ever would be using this thing in earnest. So to be honest, these large ones probably would be fine. But yeah, there's that fan. It's chonky. It's really chonky. All right, power is reconnected, and I have connected up to the 24 volt power supply on this multimeter, and this one is the 5 volt power supply right here. I'm not gonna monitor the minus 12 because it's not as important, it's just a bias voltage. So let's see what happens when we turn this on. Is the magic smoke gonna be released or what? Here we go. Okay, drive's not doing anything, but we are getting 5.1 volts here. And we're getting 24 volts there. Oh, I heard the drive click. So unfortunately, there's some stiction going on in there. Nothing. But when I turn it off, there's a click. Do I need to try to beat this drive to get it to spin, or is there just some kind of fault with it and that's why it's not working? Definitely it's getting the voltage it needs, but it's not attempting to spin. But yeah, when you turn off the power, there's a little click sound. Oh, let me check out the status LEDs on the side here. All right, well, the couple of them are on, but that's it. Now I've added the clamp meter to the purple and the yellow wire, which is the 24 volts positive, and it's set for DC, 10 amps. Let's see if this drive is drawing current. Yeah, it's about 200 milliamps. Obviously, that's not enough to spin the hard drive. So it's quite possible that this drive, well, maybe it doesn't spin up until it gets a command to spin up. So perhaps I should try hooking up this controller board here, which maybe will command the drive to spin up. And let's see if that makes any difference. Alrighty, let's give it a try now. Voltage is pretty high, 5.39 volts on the 5-volt rail. 24 volts is just fine. That is a bit on the high side though for the 5-volt rail. I do not like it at all. And there's certainly no signs of life. I mean, other than those status LEDs. Well, it's a few days later, and obviously with the wardrobe change, that's obvious. And I have spent some more time investigating this drive, and I guess I figured some stuff out. Unfortunately, nothing is particularly good news. One thing I have figured out for sure is that the spindle motor on this, which is attached to the disk itself, is not stuck. I was thinking that maybe it was trying to spin up that motor, and because it was stuck, it just wasn't doing anything. We didn't hear anything. Although that current draw we saw on the 24 volt line was a little bit too low to make sense that that was actually happening. But you never know, maybe it was trying a really low current initial spin, and then it would ramp up to speed up the spindle. The way I know that the spindle actually can turn, I can't show right now because we're gonna have to take the drive apart a little further than it is right now, but down in between this metal plate here and the hard drive, there's actually what looks like a rotary encoder. It's a disc with notches in it, and obviously there's a Hall effect sensor, and that's used by the drive electronics to figure out if the drive is spinning or not. The wheel with the notches in it is fully exposed, it's not encased in anything, so I can just stick a screwdriver down there and gently move it back and forth, and I can feel the weight of the spindle turning as I move it. So that means there's a few possibilities as to why the drive's not spinning. One is, of course, that the drive electronics does have control of whether the drive is spinning or not, and it hasn't even tried to spin the drive. Next is the motor control electronics may be damaged, so potentially the processor or whatever circuitry does control the motor is telling it to spin, like it's sending the different phases through the transistors, and there's something wrong there, so it's not getting to the motor. And finally, the most unlikely thing is that the motor itself may be damaged. I think the best thing to do at this point is take this drive off of this wooden plate so that I can remove this metal cover here, which should expose the spindle motor, and I can see electronics on this metal plate. It's like a heat sink here that are almost certainly for driving the motor. With the drive removed from the board, this actually exposed some branding and writing on this power supply. This is the dual voltage one that has 5 volts and I think minus 12 on it. This power supply was made by Power One Incorporated in Camarillo, California. It's an HCBB-75 watts, output 5 volts DC at 6 amps. There's overvolt protection, and then also has plus and minus 12 volt DC at 1.75 amps, or 15 volts, plus or minus 15 volts that is, at 1.5 amps. Anyhow, there is the side of the hard drive that we weren't seeing. There is unfortunately no writing of any kind on here, but there are Phillips screws that should remove this plate, and underneath here, like I said, there are electronics. That's what these cables here are connected to, that are surely used at least for the spindle motor and maybe for the head assembly movement. All right, hopefully the camera is focusing. So this is the encoder wheel that I was talking about. In fact, there's a Hall effect sensor right there, and this is attached to the spindle, and I can turn this. It's definitely connected to the spindle because there's a lot of mass behind this as I turn it. So those are the discs inside the drive that are moving back and forth. If you see this thing under here, this is the actual spindle motor itself. And it looks like there's a bunch of wiring right here that goes to the various windings in there. And this is a smaller lead, which is maybe some kind of a speed sensor or something like that. Although obviously with the Hall effect sensor, you wouldn't think that's needed, but maybe it's some kind of feedback or something like that. And now we're looking at the back side of the plate that I just removed. This is that cover that had those 3 screws in it. And look at these large resistors here. There's 2 of them. These large resistors are almost certainly used for power regulation. There's a bunch of transistors I haven't shown yet that are on. They're attached to this board here, and it probably shunts the extra current through these to bleed that off and lower the voltage down. Let me disconnect these 2 leads here. I think I can open this up more so we can get a better look at the board there. So there it is, Hokushin PSD, power supply device, or PSD, I don't know what that stands for. Circuit board is CB. We have a nice chunky relay here. I would assume that this gets energized to actually spin the drive spindle. And the fact is, we're not even hearing a click from this. So it kind of implies that there is no command or anything being sent to this board to actually engage the spindle motor. This is where service documentation for this drive would be extremely helpful because we can get an idea of how it's actually supposed to work. Notice right here, there are wires that are going through sort of a celastic looking seal. This is certainly for the head stepper motor assembly, and I guess the head read-write signals as well. And all of these cables on the top of the drive here go from this PCB and these other things to these connectors here, which is how it interfaces to the main PCB. Except for this wire right here, which I'm assuming is going to be the 24 volts, and that comes right off the main PCB right by the power connector here. You can see the traces for 24 volts go from this connector over to a little header here, which then goes to this wire, which makes its way to this PCB. I'm going to reconnect these cables, which incidentally had a very nice firm connection, and there's no evidence of any kind of corrosion or anything on this drive. So I don't think our problems with it not spinning are due to something like that. But I'm gonna put this back together so we can power this thing up, and I wanna do a little bit of probing around with an oscilloscope. I have the drive on the bench with its circuit board facing up because I wanted to probe this a little bit with an oscilloscope to see if it's even executing code. But before we do that though, I wanna mention that I edited together the footage that I've shot so far for this video and actually released it to the higher tiers on my Patreon page because I thought maybe some of the smart people there would be able to reverse engineer some of the ROMs that I had dumped for this, or even do a little sleuthing on Google to find some more information on this that I might not have been able to find. Let's take a look at some of the information that my patrons were able to uncover. The first message is from the Retro guy, and it says, "Hi Adrian, I found this one on the UK eBay site, and it's for the same model of hard drive." And he put the link here to the listing. And unfortunately, even though 3 days ago this link was actually working and I could see pictures of someone trying to sell a new old stock one of these hard drives, I had meant to save all the pictures that were on that listing because there were several. And unfortunately, I didn't, and they're gone now. There wasn't anything super revealing in the photos, luckily. It just showed a box for the drive. It was like in the original packing materials. And the drive that was being sold by that seller didn't have the additional host adapter on it. It just had the single drive electronics PCB. There were also a couple certification papers that said that it was QA tested, stuff like that, but there wasn't anything particularly revealing. When looking at the pictures of the drive, it didn't have these little standoffs on here that are on mine to hold that extra PCB, and it also didn't have this little thing as well. The next comment is from patron Starlight Minako, and they said they weren't able to find any information on the drive itself, but they were able to figure out that Hokushin Electric Works Limited merged with Yokogawa Electric Corporation in 1983, and there's a reference to a Japanese webpage here. They went on to say that they could not find any information regarding the drive archived on Yokogawa's website, and it didn't look like Yokogawa published any of the archival information from Hokushin before the merger. That could be also why there seems to be no information whatsoever anywhere on the internet about this drive. And lastly, a few patrons are working on disassembling the ROMs on the drive and on the adapter board. And Peter goes on to say that the dump I made for one of the ROMs on the adapter board, which is currently not installed on here, it's sitting over there, looks like it was wrong. Like it doesn't seem to have any program code or anything like that. Peter says that the ROM that's at 11K on the adapter looks like it maps into the start of memory space. And incidentally, the 8085 starts executing from ROM right at the beginning of address space. This is different than, say, a 6502, which uses ROMs that are mapped up to the top of the memory space. And that's also the same as the 8086, which uses the ROMs that are up at the top. There's a jump vector that's contained in a fixed location up in that ROM space. And the CPU looks for that when it's powered on, and then it starts to execute code from that location that's referenced there. Peter says that that ROM seems to indicate that it's looking for code to be mapped at 2000 to 2FFF, which Peter thinks would be 12E and 12K. But of course, 12K was the one we looked at in the hex editor that just had a whole lot of zeros and 80s and stuff like that. It didn't look like actual valid code of any kind. So Peter asked me to go check to make sure that I had a good dump of that. So I did. I went and stuck it in both the Retro Chip Tester Pro and in my Mini Pro, the more updated version, which is sitting right here. And I got an identical dump from that chip multiple times in both of those readers. Well, Patron Colaholiker read my reply there and thought that maybe that particular EEPROM was just used as some kind of like lookup tables or combinational logic. It wasn't actually used for executing program code. In fact, the 12E ROM chip, which is the one that's potentially problematic, is this one right here, which is nowhere near the two ROM chips that are by the CPU. So it kind of makes sense that this is some kind of combinational logic. Well, it doesn't make sense, but the fact that it's over here on its own kind of makes me think that it is combinational logic. And then here's a comment from Colaholiker again. It was on the same thread talking about the ROMs. They ask if I could power this board up and check the chip select line on this chip here, the one that has the funny dump, to see that if it's selected all the time. And if it is, that means this is used for like combinational logic, kind of like a PLA or something like that, and not as actual program code. So I think it's time to power up this drive, poke around a little bit on the main PCB, and then I'll power up this adapter here. I'll connect this up, and then we'll poke around on these chips as well and see if we're seeing evidence of any program code actually running. Potentially as well, I can probe the signaling that's going to these pin headers here, which are going to those cables that go to that power board. Maybe we could see some evidence of the square waves that are used to drive the motor. Alrighty, so on the main PCB, we have the CPU. This is the 8085 CPU. We have this, which is the 8155. It's like a programmable timer and also has 256 bytes of SRAM, static RAM. So that is used by the CPU. And then right here, of course, is the program ROM for the CPU. So this will be mapped into the start of address space. And then this here is an 8255, which I think we looked at earlier in the video. This is like also used for programmable interrupts or timers or something like that. So the power supplies are still connected here to the drives through this rainbow cable, and the sketchy AC power cord is still connected and it's hooked up to the power strip right here. So I'm going to turn this on, and I can see status LEDs on this drive as well. Oh, incidentally, remember how when I had the two boards connected, the 5-volt rail was like too high, it was like almost 5.4 volts. I was actually able to turn down the 5-volt rail on the power supply here. There's actually an adjustable potentiometer on there. So with the drive powered up, we have the status LEDs, and if I turn it off, we get the same click we were getting before, and we can turn it on, and hopefully you can see these status LEDs. There's a little bit of a change. This one was on and then it goes off. And yeah, that's it. The drive is not doing anything. Alrighty, so we're on the CPU on the 5-volt rail, and I am seeing this like weird pulsing that is happening on that rail. So I'm not so sure that this power supply is actually working properly. So I'm going to break the 5-volt connection here, and I'll use my bench power supply to power this up, because that just doesn't look right. And that rail's got to be good. Otherwise, glitching on there, that could have unpredictable results. Alrighty, the bench supply is connected. Let's power this up without any other voltages and just see what it does. Well, we're getting a nice smooth 5 volts now, no more ripple on there, so that's good. So let's turn that on and then turn on the rest of the power. All right, so now we have both those LEDs on. We're getting 2 amps on the 5-volt rail. And actually what's interesting is that pulsing is there now when I have 24 volts turned on. Is there some kind of like lack of isolation here or a short on this board? So that is a bit strange. So okay, there was nothing actually wrong with that particular power supply. So I suppose I can just hook it back up again. Okay, sorry, I doubted the 5-volt power supply. That is reconnected. Let's just see if this is behaving the same way. Yes, it is exactly the same. Check the voltage. 4.93 volts. Okay, enough talking. I'm going to turn the power on. Let's take a look at the CPU. So I have the pin out right here. We got clock signals here on pins 1 and 2. And there it is, 3.6 megahertz, which I guess is the clock frequency of this CPU. We're now looking at the reset line, pin 36, reset in. So remember, it's reset low. So when it's low, the CPU is in reset. If I shut the power off, and when I turn it on, it should stay low for a second, then go high. Yeah, and it did it. Just for a split second, it was low, and then it went high. So I'd say that's normal behavior. But you can see that little pulsing that's going on. I think that's that ripple that comes and goes. Very unusual what's happening there. Looking at the address and the data lines on the CPU, like is typical with Intel, they're multiplexing the address and the data bus lines, at least 0 through 7. The rest are independent, which is why you see them there. Okay, I'm on address line 0. Well, it's address and data bus line. I'll zoom out. That looks way too repetitive for normal operation, but could be stuck in some kind of a loop. Yeah, you see how it looks a little different initially, and now it's just stuck in a loop? Let me try a different line here. We should see a little bit of activity as it's executing ROM code. it may be stuck in some kind of a very tight loop cycle trying to run the motor or something like that. And here we are on just one of the address lines itself, the non-multiplexed ones. And yeah, you see a little bit of activity, and then it kind of falls into that repeating cycle. That looks okay though. I don't think that's a problem. We don't know how this is supposed to work, but I think this is what's going on here. I'm on the chip select line on the EEPROM, and you can see that it's selecting the ROM just ever so slightly, and that would be normal if it's executing code out of it. But if we turn it off and we look at it when we power it on, you see some more activity before it settles in. Again, normal. So it definitely seems like to me, this thing is executing code properly off the ROM. It might be trying to spin the drive. It might be waiting for a command over the interface connector here. It's hard to really know. I'm going to probe the pins here that go to that other board. Let's see if we see anything that looks like maybe motor control or something like that. And that was it. Nothing really interesting on any of those pins that go down to that other board. So that sort of implies to me that this PCB is not even attempting to spin or turn the spindle here, which I guess is not totally unusual. Obviously, we're used to hard drives. As soon as you power them up, they just immediately spin. But definitely enterprise type drives need a command to start spinning. And they do that because if you have like 10 drives, you don't want them to all spin simultaneously. You want to spin them up in sequence because you might overload the power supply. Spinning up a hard drive takes a lot more current than just running at steady state, so you want to do them in sequence. There are a bunch of test points on this PCB, so I'm just going to probe them all and just see if I see any interesting signals on any of them. Unfortunately, probing around those different test points did not reveal anything at all. Let's take a look at this Terminator thing here. So I originally theorized this thing was SASE. Here's a close-up picture of the Terminator. And the thing is that makes me not believe that this is SASE, as you can tell here that there are signals on all of these wires. These are terminating resistors. They essentially have 5 volts and ground going to them. And then there's a 330 ohm and a 390 in this one. And this one's got a 220 and a 330, which doesn't even make sense. SCSI uses, I think, 220 and 330. It basically floats the lines around 2.5 volts, and then they can either go to 5 volts or they can go down to ground. Well, this 330 and 391 doesn't really make sense to me. But the worst thing is I think there's ground on pin 1 here, but the rest of these have signals on them, which is not at all how SASE or SCSI works. Also, the 5 volt termination power pin is on a different pin than the SCSI standard, which I think is 32 maybe. I can't remember off the top of my head, but yeah, it doesn't seem right at all. There's a bunch of pins that aren't used at all, or they're not terminated at all. So yeah, I don't really know what's going on with this signal. This is obviously something custom, which I don't think is totally unusual. The Japanese computer and also the Japanese electronics industry seem to do things kind of on their own a little bit. Like transistors that are Japanese parts have a different pinout than the normal ones that were in use in the US. Bringing up the oscilloscope and looking at these pins, they are floating 2.2 volts, but they're not really doing anything. Let's cut the power and turn it back on. Let's see if we see anything like activity-wise on here. No, there's really nothing going on. Alrighty, let me put back the adapter board here and we'll connect this up and we'll see what we can see on this thing. Oh, before I do that, I need to connect the 50-pin cable, which is floating around on my bench here. All right, as you can see, the adapter board is back on. I have the 50-pin cable connected and I'm just checking the power. I'm getting 4.7 volts or so on the CPU on the adapter board. So I think it should be running properly. And take a look at this. So I'm on one of the pins that are on that 50-pin cable, and there's absolutely a communication happening right now between the adapter board and the other one. The voltage is a little bit lower, but that is interesting that there's something going on. Let's check the other pins here. So they all seem to have a signal on them. It's hard to probe because I have to kind of go on the Terminator below. Let's reset the drive by shutting the power off and on. Wow, it's like instantaneous that it actually is communicating. That's interesting. Let's look at the signals on the CPU. So let's see here, pin 1, that's the clock. We have a 6 megahertz oscillator on the CPU here on the adapter board. It's a little bit faster than I would have thought. Let's check some of the address lines. I'm not sure this thing is actually running any code right now at all. No, I stand corrected. It does appear to be doing something on here actually. So these are address lines. And we have activity. So I guess it's running code, I don't know. And we're on one of the ROM chips, and I think this is chip select here. So if I recycle the power, yep, there's some activity, and then it settles into just this occasional activity. So It could be it copied stuff into the RAM and it's running it from RAM. You know, who knows exactly what's going on here. I have the pinout for the 2716, which is the ROM chip here, the mystery ROM chip that has the bad code in it. Let's just see if pin 18 and pin 20 are low all the time, or high all the time for that matter. All right, on pin 20, it's high all the time. This chip is not being accessed whatsoever. And then looking at what are the data bus lines on this chip, there's no activity. So this is definitely not connected to the data bus. This chip is used for some other function that currently isn't actually happening. It could be something to do with like the host interface, maybe some kind of translation or whatever that happens. But the fact is, it's not being selected right now. We're not seeing activity on the data bus lines. In fact, if we look at these other two chips over here, we should see plenty of activity on the data bus lines. And yeah, we do, which is correct because they are shared with the CPU. They are talking to the CPU. Let me turn it off and on. Yep, we see normal activity. But on this chip over here, those pins, they're all just low. So there's whatever that chip does, it is irrelevant to the CPU. So I don't necessarily think that that ROM dump is bad. It's just used for a purpose that we don't fully understand. Well, that is going to be it for this video. I know it's probably disappointing to people that I couldn't get this drive at least spinning. I'd like to hear what it sounds like. But it seems like, well, it's not even trying to spin that drive. That spindle is just not doing anything. I'm not going to say all hope is lost for us hearing this drive work. Maybe if some information is found, like datasheet, service information, anything, might help us understand it a little bit better. And maybe with those ROMs which have been dumped, people who are experts at 8085 assembly can disassemble those and figure out a little bit about how this works. And the pictures might help as well. Unfortunately, one of the things about the disassembled code in the ROMs is that we still need to know how all the I/O ports work. If there are I/O ports which the code can then hit to then spin the drive, for instance, we don't know what those are. Without schematics, the idea of reverse engineering this drive, it would be a massive, massive project. I'll just throw this out there. If you're local to me here in Portland or the Portland area, and you want to get this drive in your hands because you think you can maybe reverse engineer how this works, definitely hit me up. Send me an email to the email address that's in my channel about page. I might miss comments if you put it in a comment. So definitely send me an email, and then you can come get this drive and maybe figure out how it actually works. One thing I want to add as well is I theorize that this adapter board is maybe an emulation of the Western Digital 1001 adapter board that was very common back in the very early 80s. And I think from a time period perspective, it's possible. The Western Digital board came out, I think, in 1980. And well, this drive might have come out in the same time. And in that case, I think it's kind of unlikely that it emulates the Western Digital board. I think it's more likely that it's emulating or it's following some kind of a standard that was used on Japanese hard drives from the 70s. That's probably more likely. And maybe those, if anyone can find the standard stock and we can figure out how to interface to it, maybe there's a command that can get this thing spinning. Anyhow, check out the high-res pictures uploaded to the GitHub repo. Download those. The traces should be very visible. All the ICs are visible. I know without removing all the chips, you can't really tell what's connected to what. But it's possible that some reverse engineering could be done from those pictures, along with the dumps of the ROMs and stuff like that. So anyhow, disappointing video, but I think interesting nonetheless. It shows that there was a whole bunch of technology out there like hard drives that all the information on it is just lost to time. As my patron pointed out, this company was basically belly up while it got absorbed by another Japanese company in 1983, which was just 2 years after this drive was made. So we don't really know how long Hokushin was actually making hard drives. The company had probably been around for a lot longer making other things. There's actually evidence that they made projectors and other types of equipment, but the hard drive arm of them might have come and gone in just a few years, got absorbed by that other company, and then that was that. So that's it, we're stuck. I think I'll give it a few weeks of this video being live, and then maybe I'll do that disassembly video on the second channel. So anyhow, if you liked this video and found it interesting, thumbs up. If you didn't, you know what to do. Thanks to my patrons. Their names are scrolling off the side of the screen here. Of course, thanks to them who already helped me out on figuring out a little bit more information about this thing. And yeah, subscribe, all the usual YouTube stuff. And that is going to be that. So stay healthy, stay safe. I will see you next time. Bye.